Question number 5 is kind of the reverse of question number 4. In question number 4, they gave us bits of a pattern and we had to figure out the equation. Now they're telling us the equation and we need to figure out the bits of the pattern. The nice thing is, if I do say so myself, I think number 5 is actually a little easier, because the equation is so predictable that we can extract its important information without having to guess or do any of some of those weird strategies we were doing in number 4 that might have seemed confusing. So if you're a little lost on question number 4, bear with me. I think you'll find number 5 to be much smoother. We'll start with number 5, letter A. In letter A, the first thing we have to do is kind of decode that equation a little bit. Negative 2 minus 5n. The tip-off to me is this n. Because notice how it's a regular size n compared to letter B where it has an exponent. That's tipping me off that this must be arithmetic. Because arithmetic sequences are the ones that have a regular n attached to the adder. So this is tipping me off about something else. It looks like negative 5 must be the adder, because the adder is always the number that is attached to the n variable. So if negative 5 is the adder, the other important number in an arithmetic sequence, and I'll just go back to my notes, is the initial value. So I'm using a little bit of common sense here, figuring if the adder is the one with the n, the initial is automatically the other one. And if I think about it, negative 2 is the only other number I've got, that must be the initial. So immediately, I've got some information that I can use. The initial value must be negative 2. I can fill that right into the space. This is telling me that the adder is negative 5, which means to get to the next term, I'm going to apply that negative 5, or subtract 5 in order to generate the next term. Negative 2 minus 5 is negative 7. And then if I keep the pattern going, minus 5 again, that would give me negative 12. Minus 5 again, that gives me negative 17. Minus 5 again, that gives me negative 22. And minus 5 again, that gives me negative 27. So because the equation gives me everything, I didn't have to guess. I didn't have to do any of these crazy strategies I was using in the previous question. This is way easier. And that's the nice part about these problems, is once you know enough about the equations to make some predictions, you really don't have as much guesswork to do. And these questions are probably going to go a little smoother. So I'll do one more. I'll do question letter B, and then I'll have you try some on your own to make sure that it makes as much sense to you without hearing my examples. But let's do one more to be safe. In letter B, let's interpret what we see. The first thing I'm noticing is the parentheses, which kind of looks like a multiplication. Then I see this power of n. That's the power of n structure that we always have when we deal with a geometric sequence. So this must be a geometric problem, and that's tipping me off we must be dealing with multiplying. Specifically, the multiplier is always the number that goes in the parentheses. So again, I'm getting tipped off here. The multiplier must be the 4. This must be a pattern with multiplying 4. I know that, because that's just how geometric equations look. I've seen enough of them now to notice that pattern. Now, if I go back to my template for a geometric equation one more time just to make sure, the multiplier is the number inside the parentheses. The number before the parentheses is the initial value. So, since there's only one other number to look at here, that leaves me to assume that the initial value must be 3, because it's the only other option. So let's see if we can piece this together. This one says that the initial value is 3. I can place that in the initial value spot. The next term in the sequence is where the multiplier comes in. Multiply by 4 to get the next term. 3 times 4 is 12. And if I keep multiplying by 4, then in theory I can get all the rest of the terms too. If I multiply by 4 again, 12 times 4 is 48. And if I keep doing this, and you might need to get a calculator because the numbers do kind of get a little bit big, 48 times 4 again is 192. Times 4 again is 768. Times 4 again is 3072. So, oops, couldn't see those, sorry. So now that you've seen the pattern, again, the numbers come out pretty quickly. So now that you've known enough about these equations to know what these important numbers mean, you should be able to extract that important info and quickly fill out the missing values of each sequence. In each of these remaining problems, try to do that. Try to extract the missing information. If something really looks like it's missing, ask yourself, well, where have you seen something that looks like it before? What could be there? For example, in letter C, I don't see a number next to n, but we've seen enough problems to know there's probably an invisible 1 next to n. We can probably make that assumption. Question letter E looks like it's missing something at the beginning, something plus 10n, and I'm inferring it's a plus because it's positive 10. If it was a minus sign, I would have seen a negative there at least. But then you can ask yourself, what would be here? What would you be adding by if you couldn't see it? So that might give you a hint. And if you need more hints, you can always look at the answer key. But try this question now and see if you can extract this important information from the equations to be able to fill in all of the blanks.